So for 35, a line segment with both endpoints on a circle, that would definitely be D, a chord. All right? So again, if you need this for studying later on, you can check that out. And for this one here, when it says an angle with the vertex basically means this would be the vertex of the angle right here. So when it says vertex, you're talking right there. All right? And endpoints on the circle, that would be E. All right? That would be an inscribed angle. So again, if this was the center of the circle, and these are the two radius coming out, right, that would form the central angle. So that's C. All right? When it says a portion of the circumference, all right, so that'd be like from here to here, for example, that would be an arc, which would be A. All right? Now, if you're looking at your tangent here, here's your line. Well, my line is not the greatest, but it would only touch the circle at one point. That would definitely be G, a tangent. All right? This. In this circle shown, the line DE is an example of what? Is it A, a chord, a B, a diameter, C, a radius, or D, a tangent?
B.
So what do you think?
B.
What do you think it is?
B.
Okay, why are you saying B?
No. Getting it? No. I say A.
The answer actually is A. The key reason why it's A, it's just a chord, is because Rod and everybody else, yeah, it doesn't go through the very middle of it. The line is just a little bit off. That's why it's a chord. Okay? So that answer would definitely be A, a chord. Okay? Real quickly, because you have this arc here, and this is an inscribed angle, and this is an inscribed angle on the same arc, they have to be, those lines meet equal. So therefore, the answer would be B, 40. So this guy right here is 40 degrees as well. All right? With this here, again, to figure out what this is, because this is 40, this is your arc, would have to be 42. We just talked about that. Your central angle, which is COD, it's a central angle. All right? Sorry about that. It's going to be double your inscribed angles. All right? So what that means, you'd have 2 times 40. That would be 80. So that answer is C. All right? Again, we just, like I just said, this right here, you have a perpendicular bisector. That's why this would be D, a right angle. Okay? All right. This. Right here, guys, if this is your central angle, remember, you have a line here and a line here. What special angle is that? A straight line. What do you think, Tristan? Tristan, what's the angle of a straight line? How many degrees is it? A straight line, how many degrees? What's that? Who said it? Yeah, who said that first? Is it you, Tristan? Good job, Tristan. All right, so yeah, this here, this central angle is 180 degrees, right? That's a central angle. Do you understand why? Yep. Okay, because we just talked about that. Now, just making sure you guys are at least quiet. Tristan, don't be that way. All right, so if it's 180 degrees, what did we just talk about? If this here, right, anything we talked about when it goes to the end point there, what kind of angle is that? What starts with an I? Inscribed angle. What did we just learn about an inscribed angle?
The two angles will be the same.
Right, so kind of with that, right? But we just learned, right, in the previous one, I'm going to stop then, this angle right here, angle ADB, would be 90 degrees. Okay? It might not, but it is. So then you could put the little, the little box in the corner that shows a right angle. All right? So we just answered what A is. It's 90 degrees. Now, it's actually asking you guys what the length is of chord AD. So, and I'll record this. This is D, this is A. That's chord AD right there. So what we do know now, what kind of angle is this? Yeah, it's a 90 degree angle, which another word for 90 degree angle is a? Right angle. When we have right angles, what theorem, what can we use that we talked about? What is it? Yeah, the Pythagoras theorem. So I'll put PT like you said. Oops. So you can use Pythagoras theorem because we know it's a right angle. And it always works for right angles. So that's where you have a squared plus b squared equals c squared. So do we know what the hypotenuse is? Right? Do you know what's always the hypotenuse in that? Guys, Dell, I'm going to move you if I have to, okay? Don't do that with your fingers.
I just went like this.
Yeah, and I ask you not to. You're going to move if you keep doing it.
Guys.
Just stop it, please.
Wait.
Why does it matter if I said guys or not? Just stop doing it.
But you said
No, don't. I don't want an argument. Just stop it.
The
Okay, so if you guys know anything about this, what part does what's the hypotenuse on a right angle triangle? It's the side opposite of what?
Of the right angle?
Exactly. So if this is the right angle, B and A would be the BA would be your hypotenuse, right? So that's what C is. So C is going to be what? 10 squared or 100, right? Okay. So we'll say that this side is A. That's what we don't know. We don't know what A squared is, but we do know what B is. What's B? 6. So that's 6 squared, which is 36. Okay? So you got 36. So then, yeah, you're figuring it out now. What do you have to do, Brandon? What do you have to do?
what? 34 minutes.
seriously?
Yes.
What is it going to be, Rod?
Minus 36 minutes each side.
Yeah, exactly. So what's that going to leave you?
64.
Right. And what's the square root? So to find out what A is, I got to square root both sides. That cancels off the squared in the A. And what's 64 squared? 8.
Yeah.
So this missing side here, the answer is 8. Tough crowd, Mr. Armstrong, tough crowd. All right, here we go. So, quickly, guys, I'm recording this. Hang on here, guys. So, on this, we'll know here that angle OLM is a 90-degree angle because if this is a tangent, that will form a 90-degree angle. Because we know that that's 90 and that's 55, we can add those up together. All right, and that gives us 135. Sorry, that should be 55, not 45. So that gives us 145. We know that all three angles in a triangle equal 180. So you subtract that from 145, and that gives you 35. So that's why that angle is 35. That's your central angle. You know that an inscribed angle is half of what the central angle is. That's why the P here, angle P, is 17.5, and your answer is B.